Hello, dear face. We can start.
Right. Good evening, everyone, and welcome to the final session of our 2 week workshop on fundamentals of artificial neurons and intelligent systems. Over the past 2 weeks, we have explored how the foundations of artificial intelligence, neural networks, machine learning models, learning mechanisms, and a variety of real world applications. Today's sessions bring us to an important topic that lies at the heart of building effective AI systems: deep learning model selection. As deep learning continues to transform fields ranging from healthcare and finance to computer vision and natural language processing, selecting the right model has become just as important as developing one. Different architectures offer different strengths, computational requirements, and levels of performance depending upon the problem at hand. In today's session, we will explore the key considerations involved in choosing deep learning models, understanding their characteristics, and evaluating their suitability for different applications. This discussion will help bring together many of the concepts we have encountered throughout the workshop and provide a broader perspective on designing intelligent systems. Guiding us through this concluding session is our esteemed mentor and speaker, Dr. Meher Chand, whose expertise in artificial intelligence, machine learning, computation sciences, and research driven innovation has been instrumental in making this workshop both insightful and engaging. With great pleasure, I invite Dr. Meher Chand to kindly lead us in today's session. Over to you, sir.
Uh, Thanks, dear face, for the introduction about the today's session, and welcome back to all the participants to show your continuous interest in this ongoing workshop. And today is the last session, and we will conclude. Okay, so yesterday there was some questions, and on those based on these questions, I tried to prepare one presentation so that actually the selection of the model don't depends upon one particular. So there are various features are required. We need to understand the features, then data size, data and algos. Then so all these are very crucial. So one by one, because there are so many models and some of them we try to cover during the session, will help you to choose the right model. Okay, so one there was question from yesterday. One participant was asking about how you can use uh, Google Colab for the data which we are using the previous sessions. So this will take only the 5 minutes, and then after I will share my presentation. Okay. So see, this is my just 1 minute, please. Uh, okay. And here is my Google Colab. I am going to share my screen first. You can see this is my desktop. Okay. And yes. So actually, the thing is, in the case of Jupyter notebook with Anaconda, and the simple to use the CSV file or the other data type, we are required to put in the single folder so that we can use easily. Okay, we are required to browse the folder by using the Jupyter notebook. Okay, but in the case of Google Colab, there the initial part to read the file is little bit different. So by taking one example, uh, I have a customer churning model. Okay, so this is the same I will share with you. Okay, so see here, this is the customer churning prediction, and the expression is we have IPYNB Jupyter file. So the entire group lab is also depend upon Jupyter notebook, following the same instruction. Same pattern is there. So As we are creating the file in Jupyter Notebook, in the same you can create here in the Google Collaboratory. Okay, you see here, this is the Collab Notebook. Okay, so Collab Notebook is opening. Yes. So this is the churning model. Okay, I will share this file also with you. Just you are required to upload, but how you can use this file. Okay, along with the, you can see we are required data set which we want to use here. Okay, so you can see here I have CSV file. I will download it, and this is the download. Okay, this will download in my download directory. Yes. So this is my download directory, and I save this file with the churn modeling one. Okay, because one file already exists there. So now this is very simple. Very simple. What you will do, and here on the top you can see I have put here instruction. Okay, if you want to read the CSV file in Google Colab, then from Google.colab import files. This statement is required, and upload is equal to files.upload. Okay, so by using this shell statement, you can see this will upload the CSV file by using the picker. Okay, so when you will click on it, okay, so first this file will connect with the cloud computing Google Collaboratory. As you can see here, the sign three dots are in orange color, and then it will be connected, will become in green color. Okay, now it is connected. So now here you can see the choose file. Okay, just you are required to click on it. So as soon as you will click on it, you can pick the file. Okay, so this is the churn file. Just we are required to select and open it. Okay, so the file is uploading. You can see 45, 60, 90, 100%. The file has been uploaded. Then if you want to check the file name, if you want to check the file name, you can execute the next shell. Okay, so when you will execute to get the file name, you can see the file name is char modeling one. So this is the same name as we have in the download directory. Okay, then after we are required some important libraries we define here. Just we have discussed all these library. Okay, import pandas, spd, import numpy, asnp, matplotlib, etc. So you are required to execute this entire shell. And then after, when all these will be executed, and one more thing, you are not required to upload, install any type of the library which are essential for your model. So most of all the libraries related to machine learning, deep learning are available. Just we are required to import the file. Okay, so this is the beauty of this collaborating. So here all the required models are there. After that, just we read the file in Jupyter Notebook. The same you can see here. So the data we store here, the file name here is, you can see the list of upload is inside file name. Okay, we are required to use this file name. Now here you can see this address space PD. PD is used for pandas. Okay, dot read underscore CSV. Just you are required to pass the name of the file. So when you will click on it, and you will see that there is no error. And after that, if you want to display, after that, all the steps are the same as we do by using Jupyter Notebook. Okay, so this part is important, how you can import the data in Colab, and then after all the steps which are essential for your any model, whether it is a based on data set just like machine learning, or the other models just like the deep learning or etc. So you can, in this way, you can upload the data, and then after you can use. So here you can see the tail function. The last few rows are there. If you are using the head function, so all this uh, will work accordingly. Okay, so this data set along with the file, I will share it with you. Just you are required to upload the file, both the files in Google Drive. Okay, so open the Jupyter notebook, but the other file in which we have the data set, CSV. Okay, you can put the same file in anywhere in your system. Okay, and you are required to pick the file from particular directory where the file is exist in your particular directory where you have put the file. So after that, you can see all the things are same process, all the functions which are required for the analysis, data cleaning, train the model, etc. So everything are same, and you can cross check it. Okay, some example. I think I try to present this model also. Yeah, we have discussed this model, but right now you can use the same model in Colab. And in the previously we discussed this model by using Jupyter Notebook in localhost. Okay, so this all the tasks which we perform there we can do in the Google Colab. So this is the very simplest way to use Google Colab. Just you are required. Once again, I am repeating the first step. Okay, so this is the drive which you are required. Google.colab import files. Okay, and uploaded files dot upload. Okay, so when you will execute these three statements, this will automatically upload the file, and then after you can get the name. Okay, so the store inside files. Okay, so churning model.csv. So this is the file name. Okay, so entirely this name we are using here. Actually, the this name is stored inside file name. Okay, so that's why we are required to use only at this place file name. And when we are using the Jupyter notebook to read the file, we have the file name in between quote sign. Okay, we are not required to use again the quote sign because in the file name you can see here quote churn modeling 1.csv code. Single quote you can see here. So again, we are not required to use the quote sign. Okay, so this is the simplest way, and I hope that this information is useful. How you can use the file in Google Colab. Any doubt, please? Is it clear? Okay. So now this is our main topic, and this will help you and give many answers of your many questions. Okay, and also this presentation will help you how you can choose the model and what are the required condition, what are the features from having the data set, how you can decide that which model is applicable here. Okay, so for that we are required some architecture features and real world applications. These are the other part. So see here, we are discussing from the single layer. So each model have their features. Features are very important part. And what we have done here, we choose several model. We tried to study their features and application part and how we can choose what are the classifications, and then at the end we compare all these model along with their features. Okay, so many doubts about the selecting the model will be clear very easily. So this is the single layer perceptron which we have discussed in the very beginning, and very simple to use. Okay, so there is no hidden layer, only we have the single layer. Okay, so the architecture is very simple, and when you can use uh, linear decision boundaries, fast training, low complexity, best for the simple task. And here you can see the realistic example to choose. Okay, so just like you can see the example whether the loan of a particular person will be uh, approve or not. Okay, so there are some conditions, and if all these conditions are satisfied, according to that, approve or not. Okay, so here we have the example loan approval prediction based on the annual income goal, and approve yes or reject no. So the loan application based solely on the applicant's annual income. Okay, so there is only one thing, one prediction, yes or no, true or false. So according to that, we are required to implement. Okay, and only the single layer model we can use for that. So here you can see for the rejection, if the income is less than 40,000 annual, then it will be rejected, and if the income is greater than 40,000, then it will be approved or accepted. So how to choose the SLP? The problem is the binary classification. Okay, the class are linearly separable, and the relationship between the input and output is linear. See this condition. Okay, when the input and output have the relationship which is linear, in that case we can use single layer perceptron. Okay, so this is the way, and the data is separated by the straight line, as we demonstrate in the example. If the single line separated the entire data in two groups. Okay, one is for the acceptance and the other is for the rejection. So this is the very simplest model. Now come to the next one, multi-layer perceptron. Okay, so when we have the complex data, okay, see the first when you can apply, when we have multiple features, just like the prediction of house price, okay, will depend upon its location, size, area, number of rooms, distance from the city, etc. So all these are some features, okay, and based on all these features we are able to decide the price of home. This is a very simple example. Similarly, you can take the example of the price of car. Okay, so what are the features are involved, or according to that we can decide the price of car. So when we have the multiple features are there, so according to that we can choose the model and what we are going to there. So why the MLP or machine multi layer perceptron? What are the reason? So actually the when you will observe all these things and the price of the house, the relationship between these features and the house price is highly non-linear. Okay, so the linear the relationship between the features and the price, okay, these are non-linear. There is no linear relationship. Okay, so price is a highly nonlinear, and MLP can learn complex interaction between features to predict accurate price. So in that case, we have to choose the multiple layer perceptron. So this is the way we have discussed in the example when we have the just like a disease prediction or the crop prediction. I think I have shown you the crop prediction model. Okay, so crop prediction, when you will talk about the crop prediction, so the crop don't depend upon one particular variable. There are multiple parameters along, just like potassium, soil quality, water, water level, rainfall, weather, moisture. Okay, so all these parameters will decide which type of the crop can be done in the particular environment. Okay, so in that case also we have to we can apply multi-layer perceptron. Okay, so actually the thing is how many features are there? Okay, whether these are linear or non-linear. And when we have the multiple features, in that case we have always the problem. Always it will be associated with the non-linear. Okay, so the price, as you can see in this example, the price completely depend upon the features, and when the nonlinear case is there, so this model will be applicable. Okay, so the other things we have that just like input, output, and along with we have some hidden layers. That can be one, two, three, four, depend upon the prompt, whether the accuracy, depend upon the accuracy, and several tests are required. Very long process. We have to check everything, training part, accuracy, okay, matrices, uh, all these things will decide whether the model is. But this is the architecture you can see in the very first left side. Okay, so start from left to right, and there will be several hidden layers. So features learn nonlinear relationship. Hidden layers are the nonlinear activation function, capture complex pattern, and universal approximator. So can approximate any continuous function given enough neurons. Works for both classification and regression prompt also. Okay, just like we sometimes we are required to classify. Okay, we can use this model also, and work for regression prompts also. Customizable architecture, number of the layers, neurons, activation functions can be tuned for the performance. So according to the performance, as I told in the beginning, we can increase the number of the layers and the neurons and activation function, because all these are customizable. Customizable for the performance, for the to reduce the complexity of the model and reduce the time, etc. Okay, so multiple things we have to do experiment, and according to that we have to observe, and we have to compare which model have less complexity and time span. All these things play a very important role. Powerful with enough data. If we have the more data set, okay, and complex mapping, in that case we can use this is very helpful. So more layers and neurons allow learning highly complex mapping. Okay, so according to the complexity of the data set, okay, we can increase the layers and neurons. And last one, we can have the risk of overfitting, needs to regularization, dropout, and more data for the good utilization. So all these features we have discussed in the various in the last sessions and the previous one. So lastly, you can see here the how to choose MLP. Okay, so use MLP when your data is structured tabular. Number one. Number two, use when relationship between input and outputs are non-linear. Third one, use when you have the multiple input features in influencing the output, just like you can see the in the above example. So the features, location, areas, number of room, age of house, distance from the city. So all these impact the price of house. Okay. Use of both classification, we can use this model for classification, just like for the distance prediction, as well as the price prediction, and for the regression. Okay, and last one, you can have ensure you have the enough data and apply regression to avoid outfitting. So these features which we described in the last, so all these will help you to choose the model. So every model have some specific features. We need to understand the structure, features, and linearity, non-linearity, and according to that, we are able to decide. Okay, so see the next one. Here is the CNN, convolution nonlinear network. Okay, so you can see the applications of driverless cars. Okay, so many things on the road are there. So every object have their features, and just like when we are moving on the road, persons are there, animals are there. Okay, cars, bikes are there, and some other uh, objects can be there. Okay, so all these things are very complex, and feature extraction is very important. So if we can see the a realistic example. Okay, pneumonia detection from chest x-rays images. So goal is classify x-rays image as normal or pneumonia. Okay, so the inputs we have image based. So when we are developing a model to train driverless car, so actually the objects which we are observing, we have to capture as a images. So all the images of each object are different. Different patterns are there, their edges, their patterns, etc. So all these are very helpful to detect the object, and according to that, we are able to train the model, and the deep learning concept will be able to develop this technique. So here you can see the image architecture of CNN. Okay, so input image, convolution, activation, pooling, max pooling, and convolution activation. Again, we have the, so this is the entire hidden layers of feature learning. So actually in this case, the feature learning, in the case of convolution, if we talk about, so it is the specialized deep learning structure, and particularly learn from the images, have become the foundation of the modern computer vision and are widely used in the image classification, object detection, facial recognition, medical imaging, automation, autonomous vehicles, remote sensing, and video analytics. Unlike traditional neural network that treat every input independently, but CNN automatically learn special features such as edges, textures, shapes, and object directly from new images. Okay, so the features, you can see the feature learning at this space. So as the new images or the objects are coming, so CNN learn itself. But in the case of it has the capability to learn itself from the edges or the patterns. Okay, just like if we have multiple images for the animals, we can take um, just like dog. Dog have four legs, tail. Okay, two eyes, two ear, mouth. Okay, and you can we can take the image of cat. We can take the image of lion. So all these when we can easily understand, machine is easily to understand, uh, learn from the spatial. Actually, these animals have the different size. Tail size is different. Okay, and the color is different. If we observe, just like the distance between nose and the eyes, okay, and distance between two eyes and the ears. So these are the special features which this model can easily detect and learn. So when we have the different images, and from this, when we apply this model from the deep learning and from the images, this can learn easily. Okay, to classify. So just like you can see here, from the input images, we have a different type of the images, and this is the entire learning, and finally we have the fully connected layers, and you can see the output layer. Okay, we can have the car, we can have the truck, we can have the bike, we can have the other features. So all these are the process to learn from the images. So when we have the images, and data set is required. Okay, and yesterday also we presented the model related to the MIR. Okay, so those are also the collections of the different images, and from that we can detect the particular disease. In the same way, when we are developing the model, so all these features are required. So features of CNN, what are automatic feature extraction? CNN automatically learn a hierarchical feature from the raw images. So any image when will be come to in the data set, this will analyze the entire, what are the features, objects, edges, etc. So, okay, so this will learn from the new images. Then you can see the local respective field and weight sharing. Learns pattern using small regions with the shared weights, reducing the parameters. Okay, so as you can see, for the learning purpose, the initially the weights which we are assigning to have the accurate prediction. Okay, so here uh, the weights are required to update and bias is also there. So all these will be automatically updated but in the case of CNN. Then you can see the translation invariance. Okay, pooling layers make the model robust to the small shift or distortions. Okay, as you can see, the max polling. This will help the translation invariance. High accuracy achieve state of the art of the performance in many computer vision tasks. Okay, and last one we have is the scalable and efficient. Work well with the large data set and can be scaled deeper. Okay, so when we have the large data set of the images, we can use CNN to train the model. Okay, so why choose the CNN and what are the requirements? See here, input data is the image, grid-like structures, just like we discussed in the yesterday's model. CNN captures spatial pattern like edges, texture, shape automatically. More efficient than traditional method, no manual features engineering, and high accuracy and generation for the visual task. Okay, so what are the applications or when to choose CNN? For image classification, if you are required to object detection, we can use for the face recognition, for medical images analysis, remote sensing or satellite images, video analysis. Okay, so if you want to study this type of the problem, you can choose, you can apply CNN for this type of the problem. Some of one of the participant is unmute the mic. I request please mute the mic to avoid. Okay, Sanya, sorry. Thank you. Okay, so these are the features which we have to keep in mind. Next we have is the RNN. Okay, so in the case of RNN, what are the specific features and when to choose? Okay, so when we have the we are required to predict the next word in the sentence. Okay, just like we have the example, you can see the weather is cold today because. Okay, then we have the some next sentence, and we want to predict what can be. Okay, so in this type of the problem, we can use RNN. When we have the, you can see just like we can we have the, some text and what can be the next text, just like the application in the chat GPT. Okay, so as that is also a trend model. So when we want to predict the text, we can use RNN. Okay,
Mhm.
so here we have the unfold view over the time. You can see. So initial hidden state, then we have the H1, H2, H3. So X is the you can see the X1, X2, X3, XT, and or in the upward you can see uh, the top row you can see Y1, Y2, Y3, and YT. Okay, so the X are the input at the time, and H are noted the hidden state of the time, and Y are the output at the time, and H0 is the initial hidden state. Okay, so how this will work? The input sequence is the take the sequence of the input over the time, and the hidden state update at each step. The hidden state is updated using the current input and previous hidden state. Okay, and output generation, the hidden state produce an output at each time, step by step, and many to many or many to one, depend upon the what we want to predict. So RNN learns pattern that depend on the previous context in the memory. So according to that, this will predict predict the text. So what are the features? So hidden sequential data, this is the first one. And what will be there? Process data in the sequence and maintain information about the previous state. Okay, what was the previous state? What are the information about the same? And that must be stored. Okay, then we have the shared parameter. Some weights are used at every time step, making the model efficient. And internal memory, hidden state act as a memory that capture hierarchical information. And sport one to one and many to one. Okay, sometimes if we have just like the example here, the weather is cold today because, so there can be many reasons. Okay, so this is the you can see the hidden state. Okay, so the and the flexible structure. So according to that will be predicted. But what are the previous information? According to that, that will return the value. Learn temporal dependencies, capture pattern that involve over the time, trend, context, dynamic. Okay, so all these completely depend upon the previous history. Suitable for variable length, can handle sequence of the different length. The is just like you can see in the chat GPT. If you will give the small statement, okay, that will be less accurate. If you will give the introduce some more features, this will return more accurate. Okay, depend upon the prompt whether we are giving the right prompt or not. Okay, so in the same thing, when we have the large information, okay, so according to that, we our prediction of the text will be more accurate. So why RNN? What are the requirement? How we can use the meaning of the next word depends on all previous words. So RNN, remember the context, hidden state, and use it to make accurate prediction. Okay, so many generative tools, just like we can see, we are developing, just like Grok is there, ChatGPT is there, and from the basis of the previous information, we can uh, generate the videos and the songs also. There is one app, AI app, Suno. Name of the app is Suno. If you want to write a song, okay, so just you need to put only one line, and on the basis of the one line, okay, that will generate a song. Okay, in Suno, if you will add some more features, so that will generate not only generate the song, that will convert in the uh, audio song completely with some music also. Okay, so all these, the previous information what are existing, so from that they are learning, they are generating. Okay, so this is the some application. When to choose RNN? Okay, when to choose RNN? So when the data is sequential or time dependent, and second, when past information influences the future prediction. Okay, just like the history. Okay, so what was the past history? So that always influence the modern. Okay, for tasks like language modeling, text generation, time series forecasting, speech recognition, and activity recognition. So when you want to work on these areas, okay, or you want to extract this type of the features, then RNN is highly useful. Okay, see again, task like which you want to perform, like language modeling, okay, text generation, just like we are doing in the chat GPT, time series forecasting, and the prediction, which depend upon time. Okay, so speech recognition also. Okay, so from different voices, we can recognize the speech and the activity of recognition. When sequence length is moderate, not extremely long. Okay, so these are the some features, and by understanding all these, we can decide uh, the model and we can choose. So you can see the each model have their some own features. So features play very important role to decide the model. Okay, so here we have is the long short term memory and shortly LSTM. So here we need to focus only the key. What are the key features? Okay, so the models you can see on the left hand side LSTM architecture, but the most important thing is the features. Okay, so features, and first you can see the example also. Uh, just like the example of the battery remaining useful life prediction, and one of the participant is also working on it, and these features which we are going to discuss here will help you to understand and why this model is important for you. Okay, so predict the remaining cycle of the battery based on the historical sensor measures. And what are the input features? Voltage, current, temperature, charge, discharge cycle, etc. So all these are the input features, and from these input features we can predict the battery life or battery capacity degradation. Okay, so battery degradation depends on long-term users pattern. LSTM remember important historical information even over hundreds of cycle to make accurate prediction. So this is the main reason why this model is required for this type of a problem. Okay, so over the time, many things are required to remember, and actually the features some will change or degrade. So according to that, we can predict. So overall real world application, you can see the stock price market, stock price prediction, weather forecasting, speech recognition, machine translate, human activity recognition. So these are the some applications. So if you will observe the features, you can see here, this is the most important part. Okay, solve the vanishing gradient problem. The cell state city act as a conveyor belt and preserving the information over the long time step. And a gate, just like forget input output to control the what information to keep update or output. Captures long-term dependencies, effectively learns a pattern that span hundreds of the thousands of time step. And also the flexible power and powerful works well on the various sequence tasks such as forecasting, natural language process, and time series analysis. Can handle variable length sequence and multiple features at each time step, and state of art performance in many real world application. Okay, so the mathematical part we can skip here. When to choose? Okay, when to choose LSTM? Your data is sequential, okay, or time dependent. So in a DNA also we can use this model if we someone is working on DNA. Okay, then this model is also help us to study. So the data is sequential or time dependent. Long-term dependencies exist in the data. The time gap between cause and effect is large. Okay, you need high prediction accuracy for the time series. Sequence length is moderate to long, and you have enough computational resources. Okay, so the machine is also required with the high configurations to apply this model. So this is all about the information about LSTM and when to use, what are the features, why to use. So all these are discussed in this Fine. Okay. So if you have any question, you can ask also, or also you can put your questions in the chat box. But all the questions related to all these models are there along with each slide, all the questions and the answers. Okay. So this will clear your deep all the doubts as well as deep understanding about the models, and all this information which I try to reduce in this slide will help you to decide which model is applicable according to your dataset and your problem. So here is the one more model. You can have the GRU, gated recurrent unit. Okay. This is the simplified and efficient RN for the sequential data. Some a little bit simple as compared to the previous one. So we can apply this just like you have the example of the real-time speech recognition on mobile device. And our goal is to convert the words into the text with low latency. So the input, we have the audio feature over the time, and output will be the transcribed text. Okay. So this is the pattern. You can see the audio signal, feature extraction, and GRU model which will be implemented. And at the end, we have is the predicted text. Hello, how are you? Okay. So why choose GRU? When we need real-time requirement. GRU is computationally efficient, captures context from previous audio frame, and perform with the limited computational resource. Okay, very less resource are required to compute, and good accuracy with the faster inference captured to LSTM. So as compared to LSTM model, this GRU required very less computing. Okay, so you can see here the key features, which also we are required to go through all these, and will help you for the better understanding. So simple then STM model. So GRU has only two edges, reset and update, captured to LSTM 3 gets. Okay. There is three, but here we are only two. Fewer parameters, we are required very less parameters to train the model. Okay, so the fewer parameters, less memory uses, and fast training. Okay, so as we have the very less parameters, we are required very less computing, and the computing is simple. So naturally, this will use less memory, and training can be very easy. Capture long-term dependencies, effectively learn patterns over the long sequence by controlling information flow. And fast convergence, train faster and requires less data compared to LSTM in many tasks. So, okay, so LSTM model required long data set, but here we are required very less data to train, to converse the model. And flexible and widely used. We can use this model also for work well various sequence tasks like NLP, speech forecasting, and time series. Okay, so when to choose this model? This is also the question. So at the end, all these features which we are discussing will help you to choose the model according to your prompt. Okay, your prompt will decide which model can be choose. Okay, and sometimes we have two options or three options because for the classification we have two or three models are there. So in that case, we have to compare the accuracy between all between these model. Okay, so which model can return the more accuracy and less uh, cost function. So these two are required for the testing. So we are required to test and compare between these three, and when we have the testing, and our test will decide which model we can apply for the existing problem which you choose. Okay, so but at the end you will observe that if there are some just like I saw that today there are about 15 deep learning models are there, which has been developed right now. Okay, some of them I tried to create a video file, which I will provide you. Okay, and some of them I think I choose only five models, which I am presenting here in the through PPT. Okay, so that you can have some idea. And these models are highly useful. So most of the model is CNN where we can use everywhere. Various types of problems which we are dealing in the today. Okay, so the meaning is to see the when to choose this GRU. Your data is sequential and time dependent, which are the same as we discussed in LSTM. Okay, you need faster and lighter model than LSTM. So the problem is same. We can use LSTM or we can use GRU. But if we need a faster and lighter model, in that case we have to choose GRU. You have limited computational resource. Okay, we are not able to for the uh, you can say we don't have the machines which can deal with the large data set. Okay, we have less computational resource is dependencies on the configurations of the system. Okay, just like if you want to develop a mobile app and mobile we don't have large machine. Okay, so from mobile if you want to develop the any app which is based on sequential data. So we have to use GRE. Only then this can be possible. Applications just like speech recognition, language modeling, time series forecasting, activity recognition, and you can see that in the mobile we can open the chat GPT and we can ask our queries by opening the mic. Okay, uh, through the audio input, and sometimes also we are using uh, other social media just like YouTube, okay, by spoken. So very less computing is required. Okay, we can see the frequently, like according to that we have the output. Okay, someone want to listen a song, particular song, and they not required text, only by spoken, only by giving the uh, voice output input, we can extract the particular song. Okay, so these are the some applications we can observe, and for this type of the prompt, we can use GRU. Okay, so the applications we have the language modeling, time series forecasting, activity recognition. Best for you can see the speech recognition, time series forecasting, text generation, activity recognitions. Okay, so this is the all about this GRU model. Then here you can see I tried to put all the models, their types, features, realistic examples to choose. So this slide which you can see here, so all the models which we discuss are put at this place. Okay, so we discuss about the forward network, we discuss about the convolution based network, then sequence model, attention model, you can see the generative model, graph model, and last one we have is the hybrid model. And along with there are different type of the features. Just like you can see the in the convolution, we can use CNN, ResNet, DensNet. We recently yesterday we used some of them. Okay, efficient net, vision transformer. Okay, in the sequence model we have RNN, LSTM, by LSTM, GRU. These are we can use for sequence model. Okay, and for the attention model we can use this model we don't use. Okay, we did not discuss. We are not able to cover, but here the example. So for the self attention, we can use attention model. Okay, a transform, but GPT and T5. So these are the some models which can be used, and generative models. Okay, So here we have the encoder and decoder are required. So autoencoder, a variational autoencoder, and again these are the some models which can be used. And the graph models we have CNN, GATE, GAT, GraphSeq, etc. And one participant was asking about the hybrid model. Okay, so hybrid models are the mixture of one or two model. So just like you can see in the 7 number. So when sometimes we are using two or three model. Okay, so you can combine just like CNN and LSTM, CNN and by LSTM, CNN, LSTM, attention. So three models are there. Okay, and last one we have also three models are there. We are using altogether CNN by LSTM transformer. Okay, so when to use the features will decide. Okay, features will help you. So the next row you can see the features with respect to all these models are there. You can compare what are the common, which features can separate it to the other. Okay, what are the applications, real examples. So when you will go through this entire sheet, this will help you why to choose, what are the features which will differentiate one model to the other. So the most important thing is to understand the data set and their features of the model and the features of the data also. So all these will help you to choose the model. Okay, so I hope that this entire sheet will help you. So why you can see the realistic examples are there. For forward, we have the customer churn prediction using the demographic and transaction data. And for the CNN base, we have the uh, pneumonia detection from chest X-rays, and then we have the sequential model. You can see the realistic example. Okay, so features you can see the time series suitable for the variable length, LSTM, capture, etc. So all these things are there and will help you to understand. So why to choose? So the depend upon the data set. So first you can see the data is structured and relationship are nonlinear. Second model, image data with the strong spatial patterns. Okay. Third one model, why to choose sequential model? The data has temporal dependencies and long-term behavior. And fourth model we can choose when requires understanding context across long sequences. And for fifth model we can choose depend upon the limited data availability, need more training samples. Okay, and sixth we can use data is connected rather than independent. And last one, you can see the hybrid requires a special feature, extraction, temporal analysis, global context understanding. So in that case, we have to use hybrid model. When we have the mixed features are there. Okay, so according to the some are the features related to the CNN model, some features are related to the attention or the graph. So according to that, we have to decide all this because all the features we are required to extract and according to that, we have to train the model. So in that case, hybrid model will help to develop the machine. And last, you can see the how to choose the right model. Okay, so what are the steps? So first thing is understand your data. Identify the data type, size, structure, quality. This is the very first step. Then we are required to define the goal. Classification, prediction, generation, detection, translation. What is our goal? Okay, our goal will decide which model we are required to use. Okay, match with the model category. So all the models have their different categories, parameters are required. Okay, features. So all these will help you to choose the model. So use the table above to match your prompt with the most suitable model category. Okay, so in this table, all the models are there, features are there. Okay, and realistic examples we put here, and in each model there are some uh, modeling which we can implement for different type of the problem. Okay, so according to that we can fix our features and we can choose. And in the fourth step, consider the resources, check computation, memory, dataset size, and training time. And last step, we have the experiment and evaluate. So train, validate, compare performance, and choose the best model. And here is also the some main keys to choose artificial neural network model. Okay, so this also you can go through. I will let to because this sheet is also completely based on the previous one. Okay, so I will let this file, this slide for yourself. Nothing new, but have some help you to choose the model. So this is all about how you can choose the particular model. Okay, and I hope that this slide which I prepared today will help you about the deep understanding about the various models. Okay, along with I have prepared one more file which is not in the form of a presentation but in the form of a PDF file. Okay, that file include about 14 15 models are there. So their features you must go through, but the models which we present through this PPT are highly useful, and I hope that these features will help you to choose the particular model. And once you are able to choose the model which is fit for your problem, okay, so then what we are required, that is the next part. So once you are able to choose the model is the path to achieve the target. Okay, so once we have the path to achieve our goal, so to achieve the goal, what we need. Okay, so according to that, the models, their testing, etc., we can decide, we can perform when we have the model. Okay, what are the steps are around there, and many things are we can decide accordingly. So, dear participant, this is all about the questions which was there related to yesterday's lecture, and I hope that this will help you. And many doubts which was there in the yesterday's lecture, because when I saw in the chat box many questions was there, so I decided that the concept about the models which are highly we are using for the deep learning. Okay, so this will, I think, help you to choose the model. Okay, now if any question, please let me know. Okay, सुनो, हिमानिया कह रहा, हिमानिया कैस. Okay, there are noise coming. Yes, it was over. Sania, sorry, your mic is open. Okay. Then we have the I am user of Suno. I create song and audio using it, submitting key inputs. Yes. So if anyone want to learn how we can use the Suno app to for the song, you can take help from Sania Ansari. Okay. Sir, can RNN also predict events such as the text order in commerce? Maybe actually that depend upon the program. Okay, so what are the see during the this lecture we are focusing mainly on the features. Features are everything. Okay, if you want to develop any model, okay, first you are required to see the what are the features in your data set and the size of the data set and quality of the data set. Only these things are very very important, and based on the features you can choose your model. Okay, so I tried to differentiate all these features respective to all the models which we try to present during the session. All the models, because in the very last time not possible. Okay, but this will help you what we need to choose the model. Okay, so there whenever you want you are studying any model, focus on what are the features used for this model. If you are reading some research papers, okay, so only the reading is not important if we are not focusing on the features of the model which we are using. Okay, so focus on the features of the model and the data set. Okay, this will, when you will study this type of the problem 2 3 5 papers, this automatically will help you to understand and choose the particular model according to your data set or according to your problem. Okay, problem and the features will decide to choose the model. Can I use LSTM for prediction survival events such as time to prediction of disease? Yeah, you can use. Yes, you can use. Uh, Anil Kumar, share the video, sir. Which one? Which video you want to share? Anil, you are asking share the video.
No,
You are
sir, you said you are going to share some kind of video during this session. You said, no, sir. During
pardon?
during this session, you said that some video you are going to share regarding the models.
Okay, okay. I will share. Yes. So then we have the what is the computing capacity required to run this DL, MLP, CNN, RNN in terms of the memory RAM, storage. Okay, so if you will start, actually this is also again depend upon the dataset size. But normally, if as you are a researcher, okay, you can use seventh generation and RAM must be at least 8 GB, or if you have 16 GB, that is more useful. And disk size you can use take at least have 1 TB. Okay, so this will help you for your data set as a researcher. Okay, it is Himania who uses Suno. Yeah, you can use Suno also. Very simple. ICT does GRU solve the gradient problem too? Yes, it can be used for the gradient problem also. It can be used. So now, any more question or you want to know, please you can unmute mic. So I hope that you have the answers of many questions during this session. Okay. So if you have still sir, will you do any consultancy work? Yes, I we can do. Uh, actually, we have startup also, Alin Nexora Tech Private Limited, and recently uh, this is registered for Startup India under DPIIT. Okay, and this company, what we do, this is the we are working to develop the devices based on uh, just like intelligent tools uh, by using the data set. Okay, trend model, and we are promoting them in some machines. And recently, we have developed a device for the crop prediction. Okay, we train the model and then we deploy, and front end and back end both we have done. So if you are required, we are here to help you in this direction also. Right now we have one is MathTech Thinking Foundation, and from the working with this foundation and various problems we observe, and what one problem is with researcher. One problem is the researcher, that is one problem, the researcher only solve the problem. Okay, just like one researcher, what will do? He will develop the model. Okay, and when the model will publish in the as a paper, then his work is over. But I think his work start when model is developed and published. This is the next level. Okay, so for this you need some you can say the computer expert or computer engineers. If the model has been developed and you have the accuracy, we can deploy the same as a machine, as a mobile app, as a website, we can do. Okay, so in that case, we have the team, and we are developing this type of the model. Okay, right now we have three models in this category. Okay, so one is based on MRI, sorry, EEG. Okay, so that is also we have developed, and now we are working to deploy. Actually, in the EEG, from entropy measurement for stress measure, we developed this device, has been developed, and for the patent we have also submitted it. Okay, patent will be there in a very short time. Okay, so the next level is when the model we have developed and testing has been done. Then after the next level is to deploy, to develop the machine, the technique. Okay, so that also we can do collaboratively, and we are here to help you and how we can do. Okay, so you are welcome if you are interested, Anil Kumar. Okay, if possible, please share details in our WhatsApp. Please contact the WhatsApp, sir. Yeah, you can. I will share some details and how you can connect us with your prom. Okay, actually, as researchers, don't stop your work. Actually, when you have spent a lot of time to develop one study. Okay, for that you have to collaborate with. We can open the project according to the prompt. Okay, or you can we can invite, or you can invite also for the consultancy, and we can work together. Okay, for that we have to sign MOU or the other agreement we are required according to your institute. Okay, what are the terms and conditions from your side? And according to that, either we have to do MOU or we have to do agreement. But MOU is better than agreement. Okay, so in this way we can collaborate to deploy this type of the problems. Any more question, please? Any more question? Okay. Uh, okay. Anil Kumar is asking about for data set. Please complete your question. Okay, we have a lot of data set from the. I will share the link. Okay, but it depend upon your prompt. If you are working on the cancer, we have a lot of data set from USA. You can. There is about five 5,000 different categories. but only some of that data set is used. Yes, you can contact us. Can I privately relate with you on guidance for my model perfection? Yes. Anyone have any question or you need help, you need guidance, please always feel free without any condition. Okay. So if with our guidance you have some benefit, we are here to help you without any condition. Okay. So from anywhere, any people can reach out. So the foundation was established to help the people. Okay, we are not having the particular conditions. If you will do this one, then we can do. No, there is no any condition. So without any condition, you can take help from us. Okay, from anywhere, uh, anyone can connect. Anyone can take help. Anyone can ask any questions.
Sir, one more thing, sir. This is Anil, sir. Can you suggest, as I'm working on the data sets, I'm working on some kind of data sets by using a Kaggle, and we have a ISRO data set.
Kaggle data set you can use for the learning purpose.
Yes, sir. But what
Okay.
I'm asking is, I required a practical data set, which I've seen from you, the yesterday's lecture. You might have taken some MRI scanning images like that. You might have collected from the practical data sets, right, sir? So I want to know that how can I able to get a practical data set on batteries? Any resources are available or any kind of things are available to get a practical data set from the industry? It may helpful for my research, sir.
There are some practical data set. If you will, I will share some link in the WhatsApp group. From that you can access. Okay, and one more thing I will suggest you. If you are working on which category?
Batteries, sir. Batteries, electric batteries.
Okay, okay. Uh, in India, I think we don't have such type of the depository where we can access easily. But there are some like USA or UK, Germany. There have a lot of depositories from where we can access this type of the data set. Okay, but primary data set you have to collect yourself. All these will be secondary data set, but you can use for practical. I will provide some important website link. Okay, and you can access from that place. Yes, I will share with you. I will share in the WhatsApp group some important websites from where you can access the dataset. Any more question? Dear participant, Himani, I was waiting why you were silent. Now you can open your mic. Yeah, I am not able to listen to you. Can you unmute your mic? Your mic is muted.
Okay, can you hear me now?
Yeah, you are audible.
Okay, I was saying that this training was very interesting, and especially this the today's session. I wanted to ask one thing, following up to what the previous speakers has asked. If I want to use maybe especially the convolutional neural network for image classification. If, for instance, I can go to the field primarily and I take the photos, like if I want to identify the types of crops, and I just take the photos myself, originally from the plants, I take and collect a number of photos or images of the crops of different types, and I label them. I labels that this is maize, this is sunflower, this is what, and I have
You are
maybe.
required high quality images.
Okay, so my question is,
Yeah, you are working on crop disease.
Mine is different, but I want to try out
Okay.
for application of the CNN. Yes, especially in crop production, because I'm also involving in projects related to agriculture. So if what quality of the photos, or what kind of photos, the pixels that I can take the original photos from the, do I need
HD
to
images.
get them?
HD images.
Okay.
Yeah.
And the labeling, do I label it using the algorithms, or I label it just myself? Because when you take the photos, they will be just labeled like IMG, PNG.
First, you are required to collect the images, and the dataset must be about you can say more than 2000.
Yes.
So as much you have the large data set, you have more accuracy. Okay, when we are developing any machine, intelligent machine, depends upon the size of the data. So as much we have the large data set, we have the more accuracy. So depend upon how many images you can collect. Okay, so this will help you. But before that, have you some literature study about this part?
Yes, I have seen literatures for classification of, especially when it comes to identification of disease and the NDVI. As I was telling you that I'm also dealing with NDVI images from the vegetation's classifications.
Yeah,
Yes.
image classification is used here. Yeah,
Yeah.
CNN model we can use.
Yes, one of my objectives, one of my features that I'm collecting with the prediction for population studies, I'm also classifying the vegetation classes.
Okay.
So images that are collected from the images that are taken from the vegetation cover, land use cover, with different pixels and the
Mm.
index of the
Yes,
spectra.
yes.
So images,
Yeah.
radiation, it gives you the features of the cover type.
So how many features you choose for this model?
Now for this one, because it is big data, I have taken it from the image collections that were developed by the global international organizations like Copernicus. So it's large data set. One of the collection, because it's of the whole country, it's more than 4 terabytes. But
Okay.
I have done the map reductions and the image classification on the cloud using Google Engine.
Okay.
So I just extracted the statistics from them using the pixels, taking the pixels and getting the statistical values from them.
Google Engine images also can be used, but we have to see the quality of the images. Okay.
Google Engine is for me. Google Earth Engine is just a platform for coding and the computing.
Okay.
But the images are collected. I take the images from the Copernicus, NASA, and SGS. Yes.
So, okay, we can discuss this model in the very detail. Okay, many things are required from your side also. Okay, but you can use this CNN model and very easily applicable. So, if you how much images you have collected right now? You are muted. You are muted.
Okay, I don't know if I can share. I can share my screen here.
You want to share the screen? Himanya, this will take time. This will take time. We will discuss after the.
Okay, I'll
whenever-
discuss with
okay.
you in box.
Yeah, actually, time is about, and we have to conclude the session. Okay, and validatory. So I ask to all the participants to give the open feedback, unmuted mic. Dear Faiz, now we can proceed for the open feedback from the participant. And yes, please. Face, are you there?
Yes, sir.
Yeah. Dear participant, this is the time to give your open feedback. So about the entire workshop. Okay, so your feedback is important for us to improve the quality, to improve the workflow, and what are the challenges which you face, and what we need to improve for the future events. Okay, so one by one you can unmute your mic and you can present your thought and about the workshop, whether it was beneficial or not, and what we can improve which can be benefited for the uh, next audience. So one by one you can unmute your mic. Also please open your video also. Yes, please. So I am starting from Himania. Today I want to listen what you will say.
Thank you, sir, for starting with me.
uh,
First of all, I would like to thank you for a very good training, although it was very hard for you to deliver it in days, 14 days, but lastly you have done it. And what I would just suggest for the upcoming training, especially these ones which are heavily loaded, if possible, because all the foundations and the introduction have been given, then the next sessions I would suggest you take one piece only. Like if you are dealing with convolutional neural network, then we deal with convolutional neural network practically from start to finish. We do a capstone project and we are done with it. Then everyone goes out with a practical insight of what has been done, because the foundation is already delivered. Everyone knows now the foundations, the architecture of the models, the algorithms, the mathematical foundations of it. Now we need to go deeper into practical applications. Everyone should do, and even if possible, we can be splitting into groups or rooms in the training so that we can do it practically and present the results. Thank you.
yeah, what is your opinion to organize the event offline also?
Yeah, rooms. I think rooms can be created private when we are online also for discussion. Like, but we can do it. Everyone can do programming and running the models himself, and we discuss in the rooms. Then we come back, we present it to see the challenges which we face when we are doing it. Can even be a homework kind of or a task that we do it privately. Then when we come to the next session, we present what we have found as challenges.
Okay. Okay, thank you. Next, ICT.
Wow. Okay. I'm just trying to.
Please open your webcam video. Where is your video?
Okay. Okay. Let me just try.
Yes, only. Yeah, this is the time. Yeah.
Okay.
How are you?
Fine. Thank you. Namaste.
Namaste, namaste.
Yes. It's been a pleasant time with you and with your team. In fact, the very first time I saw this advert, I was very impressed. And I was like, this opportunity I've been waiting for to get to grab some ideas and some practical skills, especially concerning deep learning models. So it's been so good, but I want to say that, in fact, I suggested in my questionnaire that maybe we can be having this quarterly or biannually, and to build on subsequent knowledge that has been acquired. I don't know if it will be good for the organizers, and then we give it more adverts. But one key thing I want to add here, it will be good during the application for you to let the participants indicate what they want to achieve from the workshop. Because, for instance, I came personally, though all the ones you gave are very thoughtful, very knowledgeable, but some of us came looking for, you can see, I've been asking you about mathematical modeling of the models, I've gotten some ideas on how to go about it, but then if participants can tell you, this is exactly what I'm looking for, by the time you aggregate all the aspirations, you will know how to crop your lecture materials based on what participants are expecting. I think that would be very helpful. And just like you said, MTTT is available to help us. Some of us can bombard you. We ask a lot. We are troublemakers when it comes to seeking for knowledge. So be ready for some of us. We'll start asking you questions. I hope you will not be fed up with us. Thank you very much.
Thank you. Thank you.
So can I off my video now?
Yeah, you can do now. You can do.
Okay.
Any other participant, please? Yes. Mohammed
Sorry
Sabir.
again, the cost is moderate. And I think that is motivational. If you make the cost too high, it can discourage a lot of people. So the cost elements, I think, is moderate and should be maintained, if I may appeal. Should be maintained.
Yes, you can.
If you make it, for instance, $50 now, if you convert $50 to Nigerian equivalents of Naira, it's huge. So the cost is moderate and should be maintained. That is my own suggestion. Thank you.
Thank you. Dilip Kumar Mishra ji. Anyone can unmute your mic. And also at the end, we have the group photograph. Harshad. Professor Harshad Darji. Sashikala. Anyone who want to share your thought or any suggestion from your side? Welcome.
Thank you so much for the session, sir. The session was very good. Actually, I joined this program to learn more about LSTM. I have learned a lot during these days. Thank you so much.
Thank you, ma'am. Thank you. Any other participant? So also I request to all the participants, please open the webcam for having the screenshot, group screenshot. Yes, I request to all the participants. Please open the webcam. I request to all the participants. Thank you. Thank you very much. Yes, Faith, now we can conclude the session.
Right, sir.
Thank you to all.
As we conclude today's session, we also come to the end of our 2-week workshop on fundamentals of artificial neurons and intelligent systems. I would like to express my sincere gratitude to Dr. Meher Chand for his dedication, guidance, and expertise throughout this workshop. Over the past 2 weeks, he has led us through a diverse range of topics, from the fundamentals of artificial neurons and neural networks to machine learning, deep learning, predictive modeling, and intelligent systems. This workshop has been an intensive learning journey covering concepts that span mathematics, programming, data science, and artificial intelligence. While not every topic can be mastered in 14 days, we hope that the sessions have provided a solid foundation and, more importantly, the confidence to continue exploring these fields independently. I would also like to thank each participant for your commitment, curiosity, active participation throughout the program. Your questions, discussions, and engagement have been instrumental in making this workshop a meaningful learning experience. As we conclude, we would greatly appreciate your feedback and suggestions. At MathTech Thinking Foundation, we continuously strive to make our programs more relevant, practical, and impactful. Your insights will help us improve future workshop and create learning opportunities that better serve students, researchers, and professionals. On behalf of the entire organizing team, thank you for investing your time and effort in this workshop. We hope the knowledge and skills gained have served as a stepping stone toward your future academic, research, and professional pursuits. Thank you once again for being a part of this journey. We wish you all the very best in your future endeavor, and we hope to see you again in upcoming MTTF programs. Thank you and have a good night.
Thank you to all. And the certificate of participation will be provided by tomorrow morning. I will share with you feedback form just after this session. You must submit it, and tomorrow morning you will get your certificate of participation. Thank you to all. And in future, if you need any help or you have question, please always feel free to contact us. Thank you very much. Thank you to all. Thank you, dear Faze, for your continuous support to organize this workshop. Thank you to all.